Scientists are sounding the alarm tonight. A massive solar storm is racing toward Earth at millions of miles per hour. Triggered by a powerful eruption on the Sun, this cosmic blast could disrupt satellites, GPS systems, radio communications, and even power grids across the planet. Experts say the impact may create stunning auroras visible far beyond the poles, but the risks are very real. So, how dangerous is this solar storm? And what could happen when it finally hits Earth? Stay tuned. Today we will talk about a massive solar storm is heading toward Earth. So before we start, make sure to hit the like button and subscribe to my channel. 1. Understanding the threat from the Sun. A massive solar storm is currently heading toward Earth, and scientists across the world are closely monitoring its movement through space. These powerful storms begin on the Sun when enormous explosions called solar flares erupt from active regions on the solar surface. During these eruptions, the Sun releases huge amounts of energy along with billions of tons of charged plasma, known as a coronal mass ejection, or CME. When this plasma cloud travels toward Earth, it can collide with our planet's magnetic field and create what scientists call a geomagnetic storm. Recent reports from space weather agencies and astronomers indicate that strong X-class solar flares and Earth-directed CMEs are becoming more frequent as the Sun enters the peak of its 11-year solar cycle, known as the solar maximum. 2. What happens when the solar storm reaches Earth? When the incoming solar storm reaches Earth, the first thing it encounters is the magnetosphere, the invisible magnetic shield that protects our planet from harmful solar radiation. Normally, Earth's magnetic field safely deflects solar particles away into space. However, during a strong geomagnetic storm, the impact becomes so powerful that the magnetosphere compresses and shakes violently. This disturbance can create electrical currents in Earth's atmosphere and even deep underground. Scientists measure these storms using a scale from G1 to G5. G1 represents a minor storm, while G5 represents an extreme geomagnetic superstorm capable of global technological disruption. 3. Why scientists are concerned about this storm. Scientists are especially concerned because modern civilization depends heavily on technology that is vulnerable to space weather. A massive geomagnetic storm could disrupt communication satellites, GPS systems, internet infrastructure, aviation networks, and electrical power grids. Even temporary failures could affect millions of people. Experts warn that stronger storms could damage transformers within electrical grids, causing large-scale blackouts that may take weeks or months to repair. One major fear involves satellites orbiting Earth. Solar storms heat and expand Earth's upper atmosphere, increasing atmospheric drag on satellites. In 2022, dozens of Starlink satellites were lost after a geomagnetic storm altered atmospheric conditions shortly after launch. 4. Historical solar storms that shocked the world. The possibility of a catastrophic solar storm is not science fiction. History has already shown how dangerous these events can become. The most famous solar storm ever recorded was the Carrington event of 1859. During that event, an enormous solar eruption slammed into Earth and created auroras visible near the equator. Telegraph systems across Europe and North America failed. Some operators received electric shocks, and papers caught fire from electrical surges. If a storm of similar magnitude struck today, experts believe the consequences could be devastating because modern society is far more dependent on electricity and digital infrastructure. Another major event occurred in 1989 when a geomagnetic storm caused a complete power blackout in Quebec, Canada. 5. The science behind solar maximum. The current increase in solar activity is happening because the Sun is approaching solar maximum, the most active phase of its natural 11-year cycle. During solar maximum, sunspots become more common, magnetic instability increases, and the number of solar flares and CMEs rises dramatically. Scientists expected the current solar cycle to be strong, but some recent events have exceeded predictions. Sunspots are dark regions, on the sun's surface where magnetic activity is extremely intense. These regions act like giant energy factories capable of producing enormous eruptions. Recent observations have revealed rapidly growing sunspot regions producing repeated X-class flares within hours. 6. Could a solar superstorm cause a global disaster? Many researchers believe that an extreme solar superstorm could become one of the greatest natural disasters of the modern technological age. Unlike earthquakes or hurricanes, solar storms can affect the entire planet simultaneously. Power outages, internet disruption, transportation failures, and communication breakdowns could spread across multiple countries within hours. Experts estimate that recovery from a severe geomagnetic superstorm could take months or even years in the worst-case scenario. Large electrical transformers are difficult to replace, and satellite damage could disrupt global communication networks. Financial systems, emergency services, healthcare facilities, and military systems all depend heavily on stable electricity and communication infrastructure. A major solar storm could therefore create widespread economic and social disruption. 7. How scientists monitor and predict solar storms. Modern space agencies use a network of satellites and observatories to monitor the sun around the clock. NASA's Solar Dynamics Observatory, NOAA's Space Weather Prediction Center, and the European Space Agency all play critical roles in detecting solar eruptions. These systems track solar flares, sunspot growth, solar wind speed, and CME trajectories in real time. When a major eruption occurs, scientists analyze its speed, size, and magnetic structure to estimate when it will arrive at Earth. Some CMEs travel slowly and take several days to arrive, while extreme eruptions can reach Earth within 15 to 24 hours. Forecasters then issue geomagnetic storm alerts so satellite operators, airlines, and power companies can prepare protective measures. Researchers are also developing artificial intelligence systems capable of improving solar storm prediction accuracy. By analyzing enormous data sets from previous eruptions, scientists hope to better understand how solar storms evolve during their journey through space. Improved forecasting could help reduce damage by giving infrastructure operators more time to respond before a storm impacts Earth. 8. Humanity's future in the age of space weather. The growing threat of solar storms highlights how connected humanity has become to space. Our satellites, communications, internet systems, navigation networks, and even electrical infrastructure now depend on conditions beyond Earth's atmosphere. As solar activity increases during this solar maximum, scientists expect more geomagnetic storms to occur throughout the coming years. At the same time, these storms remind humanity of the immense power of the universe. The same sun that provides light and life to Earth is also capable of unleashing enormous cosmic forces that can shake our planet's technological foundations. Fortunately, advancements in space science, monitoring systems, and international cooperation have improved our ability to detect and prepare for these events. A massive solar storm heading toward Earth is therefore both a warning and a scientific opportunity. It demonstrates the importance of understanding space weather and protecting global infrastructure from cosmic threats. While most solar storms produce only minor disruptions and spectacular auroras, scientists continue to prepare for the possibility of a much larger event in the future. But if you like this video and would like to see more like it, please give it a thumbs up, leave a comment, and click the button to subscribe.